Welcome to solverfy.
So this question that we're looking at, number 43, is asking us to draw all of the structural and geometrical isomers of C4H7F. And so there are 13 isomers that I've found for this compound, which is quite a bit. So I went ahead and saved some time, drew them all out. But I do want to explain the logic behind how I got each of these isomers. So the ratio of the carbons to hydrogens in this compound is essentially n to 2n minus 1. That lets us know that there's going to be one double bond in each of the isomers that we draw. Additionally, there is a fluorine group that is attached to each of the isomers. So the two variables that we're looking at here are the location of the double bond and the attachment point of the fluorine. So going through the list of structural isomers, what I did was I first said, okay, let's say my double bond is off the first carbon. And then I drew each of the combinations of isomers that would have that double bond off the first carbon and would just vary the location of the fluorine. So for the first isomer, I had my fluorine off the second carbon. Then I drew it where it was off the third. And then for my third combination, I drew my fluorine off the fourth carbon. For 4 and 5, I kept the same 4-carbon chain. I didn't pull any groups out, but I moved the double bond to the second carbon. And then there I drew each of the possibilities where the fluorine was off the second and then where it was off the fourth. For 6 and 7, I drew isomers where I actually pulled out a methyl group each time. And then I just kept the double bond where it was at and modified the location of the fluorines. So that was how I created the 7 structural isomers for this compound. For the geometrical isomers, the double bond between the carbons is essentially fixed. Like, you know, you're going to have that carbon double bond in the center of the geometrical isomer. What's going to vary is the location and the components of each of the substituents. So for my first one, I said that there were going to be 2 methyl groups as my substituent, and I put my fluorine and my hydrogen on opposite sides. So I created a trans isomer there. For the second one, I kept the isomers the same, but I switched the location of the methyl and the fluorine to create a cis isomer, where my methyls were on the same side, my fluorine and my hydrogen were on the same side. For number 3, I essentially did the same thing, except instead of 2 methyl groups, I actually went with a lone hydrogen and then an ethyl substituent. And then for number 4, I just changed the sides of the hydrogen and the fluorine. And then for number 5, I did the same process I did with the other 2, except I added the fluorine. Instead of doing a methyl group, I did a CH2 with an F, and then a methyl group over here. And my second alternative to that, I just switched the sides to create the cis and the trans isomer for each of the possible substituents. And so there are 6 geometrical, 7 structural, resulting in 13 total isomers.